Okay, we're back. Okay, so we have here, let's get my pointer there. We have convection currents going around, meeting up and forming an oceanic ridge quite often. And the lavas cool off, get heavier and heavier until they get heavier than the mantle material, and they may start to sink, especially when they collide with another crustal plate, right? That might be made of somewhat slightly younger volcanic ocean floor. Or the ocean floor has been eroded and broken down and is redeposited, and usually this material is lighter in density because of the rock composition, which is much higher in silicates, in particular light silicates such as quartz, silica, right? Silica chip, or feldspars, and other clay minerals are often lighter, right, than the dark minerals. What are the dark minerals? Well, in the mantle there are a lot of basic metal elements: iron, magnesium, lithium. All that stuff is molten in the mantle, and when it cools off, it forms a lot of heavy or dark minerals with a big metal content. Amphiboles, pyroxenes, right, are examples of these heavy minerals. Okay, and they are mined from the crystallized ocean crust by erosional processes. And when you're close to the source, close to the volcanic or the oceanic crust, like in areas such as Hawaii, which is going over a hot spot, there they get weathered and mined out first. So that's why Hawaiian beaches are often dark colored or black sand. Only if you're on a continental crust where we get deposition of weathered crust but with very few remaining heavy minerals, you're getting plain light colored sandstone, for example, right? That is what the crust is often made of: sandstones, limestones, and other carbonates. And we're going to talk about that more later on. So one form of rocks is the ocean floor, formed by cooling off mantle material. And when that happens at the surface of the mantle, at the surface of our planet, then we call them volcanic rocks. And there you see the lava flowing out of a crater, and also you get ashes spewed in the air if you're on land, right? So that was the first source of rocks, and certainly rocks on the continent. You can also go in the ocean on the edge of shallow marine volcanoes, because they rise up and they form a shallow level surface for carbonates to be deposited. An example is an atoll, right? Those carbonates are formed because you're far away from any source of weathered continental crust, for example. Far away from a source of sands, far away from other classics such as clay minerals. The water is extremely clear, and we have a solution of calcium carbonate quite often, right? And those calcium carbonate, those limes, are formed by used by many animals to create a skeleton, which is high in carbonate, especially limes or calcite. Calcite mineral is CaCO3, for those that are chemically inclined. If you have magnesium in there, calcium magnesium carbonate, CaMgCO3, then we call it dolomite. Right? And here you're looking at an atoll, very clear, far away from any other clastic sediment supply, and we have only chemical reactions. Right? If it is a little bit protected here on the rim of the volcanic and restricts flow, then the calcium carbonate content can increase by evaporation in those waters that are not freely flowing into the ocean. And that tends to create a very favorable chemistry for animals that create reefs. So on the edge of these volcanic platforms, you get often reefs growing in a circle, and then we call it an atoll. Right? But the reefs get weathered by waves and so on and broken down, and there are many other organisms that contain skeletal material that after their death is broken down into clastic carbonates, and they're being carried by the currents, often inwards into the atoll, which is an area of restricted water flow, so it tends to be more saline, higher in salt content, but also higher in calcite content, right? And it creates, especially when you have a lot of these broken down carbonate fragments, plastics, they can form deltas or tidal deltas that break through the reefs and deposit here behind the reefs in the lagoon all kinds of fine-grained deposits. Only on the highest plates there with the shallowest depth, that is usually where the water energy is highest, right? Depends, that is hydraulics, and depends on the Froude number. The shallower it is, the higher the water energy, and then you can get here somewhat coarser particles like oolite deposits or just lime sandstones forming plates of deposits behind the barriers. And going deeper in, usually there's less clastics and the water is pretty saline, and you can get in extreme forms evaporites, salt, for example, or potash being deposited. Or you can be close to the continent and you have a lot of sediment, clastic sediments broken down from the continent and other surfaces that are often exposed above water level. And the heavy minerals that we saw in the ocean core have now been removed, and it's predominantly rich in silica minerals or in carbonates in some cases if there is not a lot of clastic materials, right? And we're forming shorelines. Most marine shorelines are clastic and they form beaches and things like that. Where the water energy is shallowest and highest, or where the depth is shallowest and the water energy is highest, that is where you get the coarsest material. And when you go offshore and deeper water, then the water energy decreases and you get finer and finer materials being deposited, or sometimes none. And then you're entering the realm of carbonate deposits. Okay, so we're going to now talk about ways of these clastic minerals to be deposited, sediments to be deposited. But that is in the next section because we have now reached 20 minutes.